Declarations of variables inside the data segment include these parts. The label is simply associated with the memory address of your variable. The data type is specified by your directive, and then you can also provide the initial values for the memory that is reserved for your data. You can use ASCII-Z to reserve sequences of characters with a terminating null character at the end, and the word directive is the data type for a 32-bit integer. In MIPS CPU architecture, all data placed in the data segment is non-constant, so you can read and write all of this information. A variety of the data declarations is the situation where long strings can be split into multiple lines like this, and arrays can be formed by a list of initializer values which determine the size of your array. So here we have an example of the first dozen of Fibonacci numbers stored as integers in the data segment. You can also reserve the space using the space directive, and the space directive takes the argument which is specifying the number of bytes to reserve. In this example, the space directive reserves a space for 10 integers. Because every integer is occupying 4 bytes, we should have a space for 10 integers. Given this, we can refer to individual integers, which each one of them is 4 byte sized, by using myArrayLabel as a starting address. So this address simply points to the first integer in this array, and then as we begin to add offsets like +4, +8, and +12, we're starting to specify next element and the next one and the next one by simply adjusting the array address by adding these 4 byte increments to the location of the array element that you're looking for. If we use a zero-based index like 0, 1, 2, 3, and so forth to identify elements of our array, all we need to do is just take the index and multiply it by 4. This is actually called scaling the index. Because we start with 0, the last index will be 9, and therefore 9 multiplied by 4 will be 36. Therefore, myArray plus 36 should give you access to the last element in this array of 10 integers in memory. And a typical use of space directive is when you really don't have any values to initialize your array, but you simply want to reserve a certain space. Of course, a line of code like this deserves a good comment explaining that this is actually an array of 10 integers, because the space directive itself only takes the number of bytes and doesn't specify any type of data that will be stored over here.